Okay, we're finally ready to wrap up our launch standard on rational expressions. This is what you will need to know for assessments on it. Okay, the first thing we do is perform the indicated operation, which means to multiply. So what the multiplication step is a 1, 2, 3 step process, okay? You're not really solving for x. It is not an equation. So if you have a minus within the expression, you need to parenthesize. So pretty much all of them. Okay, now if you look at x minus 3, you know, well, it's only two terms. It doesn't have a GCF. It's not a DOP, so I'm just going to carry that over there, and then I'm going to cross that out. Okay, 6x to the second minus 96. This would be a GCF. And then we would see if we have a difference of perfect squares, okay? So the GCF here is 6, because you can divide those both by 6 as the largest number. Just 6, so not 6x. And that becomes 1x to the second minus 16. Now, what we have here is a Dobson, because you got 4 times 4, and then you got 1x times 1x, okay? So 1x, 4, 4. Now, don't forget to drop your 6 down. You can't just forget that it's there, okay? So you need to come over here. You write times 6 times 1x plus 4 times 1x minus 4. Okay, now let's look on the denominator. You got 2x minus 8. That's a binomial, so I'd look for a GCF. GCF is 2, and then we'll see if we have a DOPS after that. Well, there's a minus there, so it might be. Okay, that's going to be 1x minus 4. Now, there's no second power, so the DOPS is not there. So I've got 2 times 1x minus 4. And this quite clearly is a binomial. It's not a, that's no GCF, but it obviously is a DOPS. Okay, so plus minus x, 3 and 3. Okay, now I'm going to look x minus 3, and x minus 3 can go away. 1x minus 4, 1x minus 4. That's pretty much it. So these two parentheses are going to be part of the answer, 1x plus 4 and x plus 3. Okay, now what do I have on top that's not out? That's outside. I've got a 6, and on bottom outside I've got a 2. Okay, now 6 and over 2, you can divide them by 2, so that becomes a 1, that becomes a 3. So I put a 3 on top. You can put a 1 on bottom if you want. You don't really have to have the 1, but I'll do it. Okay, next one, same idea. 1, 2, 3. So wrap him up, wrap him up. That one just carries over to the top, okay? And wrap that up, because I need to factor all 3 of those if possible. 16x to the second minus 8x plus 1, okay? GCF and T. Okay, GCF, I do not have a greatest common factor in there. 16 times 1 is positive 16, sum of 8, and that's going to be 4 by 4, and A equals 16, okay? So since A is not a 1, we're obviously going to need 2 sets, so lead off with your 16. Break your x to the power of 2 into x times x, and then 4 and 4. You got minus 8, so you're going to have minus 4, minus 4. Now you can divide these by 4. And that's 4x minus 1. That 4 you're dividing by does not pop out. It's not the GCF, okay? So I should not see a 4 go out here. Okay, 4x minus 1, okay? So the top times 4x minus 1 times another 4x minus 1, okay? And then the denominator, we have x cubed. 1x cubed minus 7x squared plus 12x. And GCF and T. Now, we do have a GCF because everything has x. Okay, so I divide by x because that's the smallest one. Okay, and that's going to be 1x to the second minus 7x plus 12. Okay, so you're going to get positive 12, sum of 7, that's 3 times 4. Okay, a equals 1. So x, 3, 4, minus 4, minus 3, and then we had our GCF up here, x. You got to remember to pull that down with everything else. So I've got x times x minus 3 times x minus 4. Okay, and then we have the 20x to the second minus 5x. Okay, so GCF, and then we're going to see if we have a difference of perfect squares. Okay, so GCF is 5, and it would have an x with it, so I factor out of 5x. And that becomes 4x minus 1. Now, it's not adopts because there's no second power. If it had a second power, it would be, but it's not. Okay? So times 5x times 4x minus 1. Okay? Now you start canceling. 4x minus 1, 4x minus 1. Now you can't cross out all three of them. It has to be 1 and 1. And that's all I can cancel out. So I'm going to have the 4x minus 1 on top. And on bottom, I'm going to have an x minus 4, and I'm also going to have an x minus 3. Okay, now look at your outer factors. You got 15x third, and then you got x and 5x. So you got 15x to the third on top, then x times 5x would be a 5 with x to the second. Now you can divide these by 5, so that's a 3, and that's a 1. And for x third and x second, you take away the x second, and then that goes down 2, so it becomes x. So I have 3x on top, and if you want to put 1 on the bottom, whatever floats your boat. Okay, so that's definitely going to be on the test. Okay, now the next after that comes some equations you have to solve for the x variable. Solve means find what x equals. Now, how many ratios do you have? You just have 2 of them. Okay, so I just need to label A and B together, C and D, and I solve it with a proportion. Okay, so equals, okay, A times B is always equal to C times D in an equal proportion. So 3 times 2x plus 4, and then C is going to be 1x minus 3. If you want to make it plus negative 3, go for it because you're going to have to multiply. And then D is 1x plus 2. Okay, now drop your equals, and now we multiply. Okay, I take 3 times 2x and 3 times 4, and that's 6x plus 12. Okay, now on the other side I need to FOIL. I need to take 1x times 1x. I'll put that there, 6x and 12. 1x times 1x, I got to take 1x times positive 2. I take negative 3 times 1x and negative 3 times 2. Okay, so that's 1x to the second, that's 2x, negative 3x, and negative 6. So I have 1x to the second. Add your x terms, that's negative 1x, and then negative 6. Okay, now, after this is all multiplied, you can see that we have a second power x, so there's 2 answers. And not only that, if you look at all your x's, they're not all like terms. So you need to move everything to one side so that you can factor the expression. Minus 6x, that goes nicely with the negative 1x, minus 12, minus 12. And I'm going to put this on this side, so I got 1x squared. Negative 1 minus 6 is negative 7x, and then negative 18, and then over here it's 0. Okay, so it is a trinomial, so GCF and T would be the way to solve it. Okay, GCF, I don't have one. So negative 18, difference of 7, that's going to be 1 and 18, no, 2 and 9, yep. Okay, so A equals 1 here. So XX, 2 and 9, and then it's minus 7, so it's minus 9, and difference is plus 2. Okay, so to get my two answers, x plus 2 can equal 0, or x minus 9 can equal 0. So I'm going to minus 2 from each side. I get negative 2. Plus 9 to each side, I get 9. Okay, so when you have two ratios and you have to solve, you just use your A, B, C, D, multiply out, move everything to one side if you have an x square, if all your x's aren't like terms, and then you can go to town on your factoring. Okay, now my next one. This time I count three ratios. Okay, so with three ratios we need to make three extended ratios because we need to come up with a lowest common denominator. So I need to parenthesize things. That would not. That's outer, and that one. Okay, now you see if you can factor those. So I dropped the 1 down, and that there's no GCF to that, and it's not a DOPS, so that's going to just remain the same. You can't do anything with x plus 1, okay? And x would, of course, just stay the same, and then 13, and then x plus 6. So I did not have any expressions to factor. Now, LCD, we have a parentheses x plus 6. We have outer x. Remember, that's what that's called, outer x. So when I'm counting them, outer x's, the ones in parentheses don't count, okay? And then x plus 6, already have that. Okay, so x plus 6, I have 1, 0, and 1. Okay. Okay, so the one with 0, I need to put my own x plus 6. Okay. That is times. Outer x, that has no outer x. Okay, that's an x inside. That has 1 outer x. That has 0 outer x. So the first and third need their own outer x. Now again, what I like to do is put the x in front. Outer ones I like to go in front of my parentheses. That's just the way I like to do it. Okay. All right, now what that accomplishes is now I can just forget about the fractions. Okay. And now I can set up my equation here. Now, over here you pretty much know 13 times x is 13x, or that's not brain surgery. Now this one here, you can go to your Math Papa calculator and punch in 1 times x, okay, plus parentheses x plus 6 times parentheses x plus 1. Okay, close that. That's x squared plus 6x plus 8x plus 6. Okay. Okay, now if you don't want to do the Math Papa calculator for whatever reason, you take the first one and write 1 times x, and then you take the second one, you put x plus 6 times x plus 1. Okay. 1 times x is 1x, so that'll just drop down. Now over here you got a FOIL. X times x, x times 1, 6 times x, 6 times 1, so it's going to be x a second with a 1, 1x, 6x, and 6. So 1x second, and then we have 7x's plus 6. Okay, so I've got 1x a second plus 8x plus 6, exactly what it said it was going to be. So you don't go A, B, C, D, you got to do your LCD. Okay, so now that that's been established, I know there's two answers. I know all my x's are not like terms because we got x seconds mixed with x's, so I need to minus 13x. That would go here, so 1x squared minus 5x plus 6 is 0. Okay, so that's 3 terms, so I go with my greatest common factor, and then my T-chart, there is no greatest common factor. I have positive 6, looking for sum of 5. That's 7. That's 5, okay? So A equals 1. So I can make 2 parentheses, XX, 2 and 3. So I got minus 3 minus 2. So x minus 2 equals 0. X minus 3 is 0. And the answers are going to be positive 2 and positive 3. Okay, so when you're solving, remember, if there's 2, you just go A, B, C, D, multiply everything out, move everything to one side. If you have a mixture of x's, this one, you got to go with the LCD, okay? You can use your math pop on the LCD, okay? Okay, the next one. So far I've made 80 of 120 field goals. How many field goals would I have to make to raise my average to 75%? So we're raising our average, okay? So right away it's ratios. This side is what I want my ratios, my average to be, and I want it to be 75%, and then a percent takes 100% as its denominator. Now I've made 80 of 120, but that is not equal 75%. I need to add to how many I make, and then that automatically then adds to how many have been attempted. That's how it works. Okay, and there's just 2 of these, so A, B, C, D. Okay. Okay, so A is 80 plus 1x, and we'll be multiplying that by, wait a second, I totally messed it up. B's here, A, they got to be diagonal, and that's D. So B is 100, C is 75, and D is 120 plus 1x. Okay, and then we just multiply. So 80 times 100 is 8,000 plus 100x. 75 times 120, 9,000 plus 75x. And on this one, all my x's, all of them are like terms. So let's first get those together. We don't need to move everything to one side right away. Okay. Okay, so I have 8,000 plus 25x equals 9,000. And then I can get my 8,000 over here. So 25x equals 1,000. And then if I divide by 25, 1,000 divided by 25 is 40. So x is 40. Again, you can always check your answer on the average ones, because if I've made 80 and now I make the next 40, that's 120. And then 120 plus 40 is 160. If that's 75, I did it right. Okay, number 8. 2 jets fly at the same amount of time. One jet flies 1,200 miles, while the second jet flies 1,000 miles. If the first jet travels an average of 50 miles per hour faster than the second, how long are the 2 jets flying in the air? So we're not talking really averages here. We don't want the averages to change. So we want to know how long. Okay, so it's going to be hours. And there's only one answer because they fly for the same amount of time. Okay, so I've got hours as a unit and miles. So x is hours, y is miles. And then miles per hour rate is unknown. It says 50 miles per hour faster. Well, what that means is that the miles per hours that I don't know, okay, I'm going to pick a variable. I'm going to use R because it's your rate of change, I guess. So R plus 50, and then the other one's just R. You can use any letter you want, but one's plus 50, the other one's just the regular. Okay, the average is the same, so they are lines, but they are direct variation lines because without any hours of travel, we don't get any miles, so it's a direct variation. Okay, so I just need 2 ratios here, and the times are the same, so that means the distances divided by the speeds have to be the same. Okay, so my distances I know one goes 1,200 miles and the other one goes 1,000 miles. And my speeds are unknown, but that's why I have these. I've got R plus 150, okay? And the other one's just going to be R, and I can go A, B, C, and D with this. can use your diagonal proportions. Okay, so A, 1,200, and B is R, 1R. C is 1,000, and then 1R plus 150. Okay, so this is pretty easy distribution. You're just going to have 1,200R. Then you're going to have 1,000R. Then I take 1,000 times 150. 150,000. Okay, my variables are like terms, so let's get them on the same side. So that's going to be 200R equals 150,000. Okay, so I take 150,000 divided by 200. 750 is the rate of the slower plane, 750 miles per hour. But that's not the question you're being asked. There's no way this took 750 hours. You now found that R is 750, so to find the times, you go take R out and replace it with 750 in both of them, okay? So I'm going to, on bottom, I'm going to quick take 750 plus 150, and that's 900. So I'm going to take 1,200 divided by 900, 1.3 repeating. And if this is the same, I know it's right. Yep, it is. So that's your answer, 1.3 hours. 1 1/3 hours, it means 1 hour, 20 minutes. Okay, I don't need that, though. Okay, and then there's this one. Together, you and a friend can type 50 pages of a report in 3 hours. You can type twice as fast as your friend. How long will it take each of you to complete the job alone? Okay, so how long, meaning they want to know the hours, and there's two answers if we were working alone. Hours and pages. X is hours, Y is pages. Pages per hour, don't have that, okay, so leave it empty. Now we are working together, so it's just one line, but without any hours, we're not going to get any pages done, so that's direct variation. Now this one is not going to have just two ratios, there are three, because there's us together, and then the addition of us separately, okay. We need to put our time unit in the denominator. The X unit, the time, always goes in the denominator. Pages, pages, pages. Okay? Okay, so hours. If we work together, we can get 50 and 3. But if we work separately, we're still going to have to get 50 pages typed. Now, the hours is the fact that one goes twice as fast as the other. So this guy's 2x and this guy's x. Now, you can't do the A, B, C, D because we have three ratios. So when we have three ratios, we look for our LCD. Okay. And you shouldn't need math pop a calculator on this because you don't have any parentheses that you need to FOIL or anything like that. So we have outer 2. Outer x, another outer x, and then outer 3. Outer 2, I got 1, 0, and 0. So I'm going to times 2 times 2. Oh, I'm sorry. I'm just going to drop everything down first. So I got more room to work. So times 2 times 2 times 2 times 2. Now we're set on 2's. Outer x, 1, 1, 0. Okay, so the 0 needs its own outer x. Okay. Outer 3, 0, 0, 1. So in the zeros, we need times 3. And say goodbye to the denominators. Now this is going to be easy because there's no parentheses really. 50 times 3 is 150. 100 times 3 is 300. That's going to be 100x. So I can just add these to get 450, 100x. So I divide by 100, and I get 4.5 for x. Okay. All right, so one took 4.5 hours. That's actually the faster one, and the other guy, it takes twice as long. So I take 4.5 times 2 is 9. Don't ever divide the first answer by 2, because the one you always get first is the guy who takes less time. Okay, last one. Working together, you and a friend can paint 4 houses in 6 hours. Your friend paints twice as fast as you. How long will it take you to cope to, is what that should say, to paint the 4 houses working separately? So how long? That's hours. And there's 2 of them to find because separate. But they do start off working together. So hours and houses. Okay, per houses per hour, I have no idea what that is. Okay. They are working together, so hence one line. But without any hours, you don't get any houses. Direct variation, that tells me ratios would be the way to go. The units have a proportional relationship. Okay, so together they can do, by the way, you got to have your hours on bottom. They can do 4 houses in 6 hours. If they're working separately, they'd still have to get 4 houses, but then the rates are unknown, but we know that one's twice as fast, so 2x and x. Okay, 3 ratios, you need to make 3 extensions instead of the A, B, C, D, and then find your LCD. So you got outer 2, outer x, and outer 6 this time. Okay, so by the way, everything just drops down. I don't need to worry about factoring or parenthesizing anything because there's no addition or subtraction within the actual expression. Outer 2, I got 100, so got it times 2. Outer x, I've got 110. Okay, outer 6, 001. So times 6, times 6, times 6, times 6. Forget the bottom. Okay, you know you're going to have 8x on that side. You're going to have 24 plus 48 on this side. So that's 72, 8x, divide by 8, divide by 8, x equals 9. Okay? So it takes that guy 9 hours to paint the 4 houses. He's actually the faster one. And then to find how long it takes the other one, we times it by 2, and that's 18.